You don't need to turn your life on its head. Often, making little changes will make a big impact. My name is John Thomas T. Hermoso, the Tribe 4 leader HEXAHEDRON, and we will discuss and present a video lesson that can help you understand more about logic.
Logic. We all know that we use logic in our everyday life, right? But sometimes, we do not know what logic is, and we do not know that we are using it in our everyday life. So, come with me and let's know what's the meaning of logic. According to Wikipedia, logic is an interdisciplinary field which studies truth and reasoning. Informal logic seeks to characterize valid arguments informally, for instance, by listing varieties of values. But if we are going to talk about mathematics, logic belongs to general mathematics subject. According to my research, logic in mathematics is the systematic study of valid rules of inference, the relations that lead to the acceptance of one proposition or conclusion on the basis of a set of other propositions. Ayon sa unang kahulugan ng logic, ito ay pag-aaral ng validity ng isang statement na kung saan pwede tayong magkaroon ng proposition. Gamit ang logic, pwede rin tayong mag-analyze at magbigay ng conclusion base sa isang statement na meron tayo, whether it's valid or not, by analyzing its proposition through logic. So, another definition of logic is it is a particular method of reasoning. The system or principles of reasoning applicable to any branch of knowledge or study. Logic has also related topics, which are the proposition, truth table, and different connectives. In truth table, we can see the output, validity ng isang compound statement. From the world itself, logic, we can analyze the statement based on different concepts and rules. That would be all.
Going to discuss all about statement. Let us define what is statement. We define statement that is a declarative sentence that conveys information. It means that it gives information in a mathematical statement. Statement is also a declarative sentence that can be classified as true or false, but not both. It's said that statement is a declarative sentence because question, commands, and stating an opinion are not statement. It is either true or false. Proposition can be joined by logical connectives such as and or. We can write logical statements in terms of symbols. We represent the statement by letters such as P, Q, and R, and we use the following symbols for and, or, and not. Note: it may not be necessary to determine whether sentence is true to determine whether it is a statement. A sentence is a statement as long as it gives information even if the statement is false, because not all the time the statement is true. We come now to the examples. First, today I have math class and today is Monday. This sentence gives information that the person has class today because it's Monday. Second, x raised to 2 is written in mathematical expression. This one is an example of a statement because this can be true if x is 5.
And my assigned topic is about quantifiers. So in this presentation, I will discuss quantifiers and we will see some examples related to quantifiers. So let's start. Quantifiers are words that refer to a quantities such as some or all, and also it tells for how many elements a given predicate is true. Quantifiers are words that express quantities without telling the exact number. Example, can I have some water? That sentence used the word some without telling the exact number. In mathematics, we use quantifiers. And also, it is very important when we are considering predicate logic. And it is helpful telling us that how many elements in a given predicate is true or how a particular sentence is true. So let's consider the two types of quantifiers. The first type of quantifiers is universal quantifiers and the second one is extension quantifier. So let's consider example of quantifiers in mathematics. Example, let Px be a statement x plus 1 greater than x. So what will be the truth value of P1? So P1 is equal to 1 plus 1 greater than x. So we can replace x as 1. It is equal to 2 greater than 1 and it is also true. So the truth value of P1 is true. Second, what will be the truth value of P2? P2 is equal to 2 plus 1 greater than 2, which is equal to 3 greater than 2, and it is also true. So for the continuous the same, for all the positive integers, Px is true. Integers we will take, Px will always be true. So Px is true for all positive integers x. So I can say that this particular notation stands for all, and this also a quantifier. This x is our positive integers, and we are quantifying the note that this Px is our predicate, and this particular notation stands for all. And we can saying that this for all positive integers x, Px is true. For all positive integers x, Px is true. So let's consider one example. Let Qx be the statement x less than 2. What will be the truth value of Q1? Q1 is less than 2 and it is true. But what is the truth value of Q2? And we can see it is false because 2 is not less than 2. And it is similar to Q3, Q4, and so on. This will be false. This is true with Q1, and the rest of the positive integers, this will be false. So the question is there some value of x for which Qx is true? Yes, I'm considering if domain is a set of positive integers x. Because the question is there some value of x for which Qx is true? Yes, Qx is true for x is equal to 1. So therefore, there is an x for which Qx is true. Or we can say that there exists some x for which Qx is true. This particular notation stands for there exists. That would be all. Thank you.
Good day, my name is John Thomas T. Hermoso from BSED 1H, and I'm going to discuss the logic statements. Logic statements. Every language contains different types of sentences, such as statements, questions, and commands. Example, is the test today? Is the question. Go get the newspaper is a command. This is a nice car is an opinion. Denver is the capital of Colorado is a statement of fact. A statement. A statement is a declarative sentences that is either true or false, but not both true and false. When locating a statement, it may not be necessary to determine whether a sentence is true to determine whether it is a statement. For instance, consider the following sentence. Yosemite National Park is located in California. You may not know if the sentence is true, but you do know that the sentence is either true or it is false, and that it is not both true and false. Thus, you know that the sentence is a statement. Example number 1. Identify statements. Determine whether each sentence is a statement. A. Florida is a state in the United States. Therefore, Florida is one of the 50 states in the United States. So, the sentence is true and it is a statement. Number 2. How are you? The sentence how are you is a question. It is not a declarative sentence. Thus, it is not a statement. Number 3. 9 squared plus 2 is a prime number. You may not know whether 9 squared plus 2 is a prime number. However, you do know that it is a whole number larger than. So, it is a prime number or it is not a prime number. The sentence is either true or it is false, and it is not both true and false. Number 4. X plus 1 is equal to 5. Therefore, x plus 1 is equal to 5 is a statement. It is known as an open statement, and it is true for x minus 4 and it is false for any other value of x.